Well, we're getting a pretty full Zoom lobby, so I'll go ahead and kick things off by starting off with the agenda here. Once again, thank you for everyone for your time and interest in today's topic and for joining today's webinar. This session is going to be opening up the door for growers and other stakeholders to really seek advice from an experienced set of panelists who are industry leaders. As we all know, lighting is one of the most important factors for optimizing plant growth in controlled environment agriculture, or CEA. But unfortunately, there are a whole lot of misconceptions abound related to LED's effectiveness and feasibility that's mitigating LED adoption in CEA. Today's panel will be laying out and breaking down popular misconceptions and major concerns utilizing LED lighting solutions that growers face. Topics to be covered include LED lighting performance, things like going smart, or how LED switching to LEDs will interact with your other processes, and general feasibility of LED lighting in controlled environment agriculture. So I'll be starting off the call by introducing you to the panel, but first, make sure as the webinar is going on that you're entering your questions into the chat. As I said, today's panel will lay out and break down these common misconceptions for growers around LED lighting. If you don't hear your specific questions or myths that you're aware of, let us know. Message those questions or statements or facts or whatever it is you've got to share with us and hope we can talk about in the chat. And we'll be keeping an eye on that and trying to incorporate it into either our conversation or the Q&A session at the end of the call today. So moving on to our panel here, as you can see, I'm the moderator on the left. I'll be setting up the call, introducing the rest of the panelists, and kind of playing a timekeeper role to make sure everything's moving on track. We've got John A. Wilson, who is the founding director of Fernhill Shopworks, a market research and strategy firm serving utilities and the lighting industry. John's been active in the cultivation community since 2006, combining 15 years of utility and lighting experience with 15 years of growing. His current passions include soul jazz, summertime, and baseball on the radio. And today, John will be kicking off discussion with each of the panelists to better understand what role LED lighting has in controlled environment agriculture. We also have Lior Radetsky, a senior lighting scientist at the Design Lights Consortium, focusing on developing lighting solutions that promote energy optimization, quality, human factors, and performance in the areas of horticultural and architectural lighting. Lior has over 20 years of experience in the lighting industry as a research scientist with the Lighting Research Center at Rensselaer Polytechnic Institute and as Director of Customer Education at Lighting Analysts, Inc. We also have Dr. Eriko Matos. Dr. Eriko is the Executive Director of the Greenhouse Lighting and Systems Engineering Consortium, GLAZE, and co-founder and CEO of Canopy. Eriko earned a PhD in 2013 from the University of Georgia and a BS from the University of Sao Paulo in 2009. At GLAZE, Eriko works with academics and industry stakeholders to facilitate the development and implementation of new technologies aimed to improve CEA food production sustainability. At Canopy, Eriko is leading the development and implementation of new lighting control technologies to increase greenhouses' lighting energy use efficiency and maximize operations profitability. Also, in 2019, just as a side note, Eriko was recognized by Produce Grower magazine as a produce pioneer for his contributions to the CEA industry. And then rounding off our esteemed group of panelists here, we have Lauren Morlino, who is technical manager at Evergreen Consulting Group. While she is focused on DTE energy efficiency programs, she is a resource for controlled environment agriculture programs across the country and internationally, actually, because I know that she works with me and we talk with Canadian folks. Also, Lauren specializes in researching and prototyping exciting, innovative, and efficient technologies and services for customers, especially for CEA and underserved communities. During her career in the energy efficiency industry, Lauren has researched and designed initiatives for lighting, controls, refrigeration, consumer electronics, and CEA systems. So as you can see, we've got a really great panel here. We've got a lot to talk about. So now that I've introduced everything, I'll go ahead and hand our virtual mic off to John Wilson, have our panelists come back onto camera, and I'll see you all in a little bit.
All right, excellent. Well, thank you so much, Casey. Thank you to the DLC, and thank you to everybody who has joined us for this hour. I'm really excited for this conversation, and I'm excited to be a part of this panel because the three folks that Casey just introduced are all tremendous resources, and it's awesome to have them all together. So Casey sort of described at a high level these three focus areas that we're going to hit, but let me just provide a little context before we go there. My role in this webinar today is to help sort of represent the voice of the growers, represent the voice of the cultivation community, and pose some of the questions that I've heard and also that you submitted to our expert panel to help to ask them to respond and provide us with their informed responses. So the three myths specifically that we're going to talk about are, the first one is LEDs can't compare to my current lights. We're going to talk about, LEDs will negatively impact my operations. And we're going to talk about LEDs are unaffordable or untrustworthy. Those are the sort of three major myths. There's dozens and dozens of questions that came in from y'all when you registered. It was awesome, really fun to review those, and generally they all kind of fell into those three major categories, and it was kind of cool to see how that came together. So we're going to tackle those with our three expert panelists here, but before we get into that, something I thought that would be worthwhile, and this came up when our panel was talking and planning, is everybody's looking for simple answers. We all crave assurances, but the fact of the matter is there just aren't a whole lot of simple answers out there, especially when it comes to this stuff. And I love it. I always hear growers say, no, I understand that. But if I'm just trying to grow sativas that got, that jack in them, what lights, what spectrum do I want just for that? Yeah, I know it's not for everything. And I wish if I had that information in my pocket, heck, folks, I'd be doing something with it, believe me. So there's not always simple answers, but the folks that are going to provide us with, information today, they're going to give you, they're going to provide just some awesome information to help everyone make informed decisions. So we're going to move right into this first one. And Casey, maybe we want to bring the first slide up for myth number one: LED lights can't compare to my current light sources. And before I cut Leora loose on this one, let me just summarize a little bit of what I've heard from folks in the market, and Leora, you can respond to it. So I think the first comment I hear, and the reason I know we wanted this one to be first, is just so frequently people say, look, LED, it might be nice for that little closet boutique operation, but it just can't compare to my, 1K double-ended HIDs. There's no way. And when people say it can't compare, I think we're going to unpack that. They're talking about quality, they're talking about production, but I think people are also saying, I don't know how to compare. I seriously, how do you compare? Can we compare? So Leora, why don't you open up the panel for us and talk about how do we compare LED to HID, and how do they compare?
Thanks, John. It's really nice to be with everyone today. I'm going to take a quick shot at trying to answer those questions. I've got a few ideas, but again, please bring something up in the chat if we don't answer it, and we're going to try our hardest to answer it in the very last 15 minutes or so. So let's start about what we can compare. So first of all, LEDs have come a long way in the past 7 or 8 years, especially for CEA. As of just last week, we have almost 500 LED fixtures on the DLC's Horticultural Lighting QPL. And these are products that have been tested in many different ways, both in terms of performance, in terms of life, in terms of reliability. And we look at that information, and if it meets our criteria, we list it on our QPL. So I want to share some of the data that we have with you today and see if it can help answer the questions that you might have. So the first thing I want to show you is the data that we have as of just a few days ago And what I've done is I've binned it in terms of light output. And in this case, what I've done is I've used a metric that is common in CEA to describe the light output of these grow lights, whether it's HID, HPS or LED, we use the same metric. And that metric is photosynthetic photon flux, or PPF. And it's really important that we use that specific way of summing up light output instead of lumens to compare how products compare against each other or compare to older products. And that's because if you use lumens instead, you're really discounting the red and blue potential spectrum that is in that grow light. So there's a common grower saying that lumens are for humans and PAR is for plants. And in this case, it's really PPF that's for plants, because what it's going to do is it's going to make sure that we count those red and blue wavelengths that are in the spectrum. So looking at this graph, you can see that there's a wide range of performance in terms of light output that's on the QPL. So you can find products with less than 500 micromoles per second or less than 500 ppf, all the way up to greater than 3,000. So of course, the next question I would have is, okay, so what? How does that compare to the technology that's been around for 30 or 40 years, or even newer HPS technologies that are out there? And so at least on the basis of total light output, we're not going to talk about distribution yet, but total light output, it's really easy to see that there's a lot of products across the spectrum that can meet your needs. So for example, if you've got a 600 watt single-ended HPS fixture or a 1,000 watt single-ended metal halide fixture, you're going to have somewhere between 500 to 1,000 micromoles per second out of that fixture. And that accounts for some assumptions on the fixture performance itself, right? You're not going to get the total lamp output on your crop. And as you can see, there's 100 luminaires, LED luminaires on the Hort QPL that are equivalent to those types of products. There's even more products that are equivalent to 1,000 watt double-ended HPS fixtures or 1,000 watt double-ended metal halide fixtures. As you can see, there's almost 300 products that are available here. So I think that regardless of the kind of light source that you have been using or that you've heard about, in terms of light output alone, it's really easy to find LED fixtures that not only compare, which means you can replace them on a one-for-one basis, right? You can place one HPS fixture with one LED fixture, but because of the mounting height differences, because your LED fixtures are potentially a lot closer to your crops, you have even more gains to be had in reducing that light output and saving energy down the road. So I think the future is really bright in 2021 for LED luminaires, replacing the incumbent technologies. Now, the other side of this is the energy side, right? Of course, you want to make sure that you're providing the DLI that you want to provide, the PPFD that you want to provide, so that you can get to grow your crop and optimize that crop, right? And so even if you choose the same PPFD or even a higher PPFD than you're currently using, with LED, you can save energy because their efficacy is as high as the best performing HPS product. And in some cases, 50 to 70% higher, as you can see from this graph. You're going to be saving energy and being able to provide the right light levels. And this graph shows you bin for efficacy, the number of products in each efficacy bin on the x-axis. So we have less than 1.9 micromoles per joule, very few products on the QPL. Right now, that's our minimum threshold. Quite a few products under 2.2, and then the sky's the limit, right? You can see that we've got 150 products that are between 2.2 and 2.5 micromoles per joule, over 200 products up to 2.8 micromoles per joule, and then we even have 50 or so products above 2.8 micromoles per joule. And this number is increasing all of the time. Now, one of the things that's happening in the market is there are regulatory agencies that are providing different ways to save energy and still comply with the regulations. So one of the things that's nice about LED is if you use the minimum PPE compliance pathway, for example, that Massachusetts and Illinois provide, you can use more efficient technologies and choose the light level that you want to grow at. The opposite way is to cap your LPD, essentially to cap your PPFD levels and then be able to use the older technologies. And that's a way of balancing energy efficiency and production. So the last question that we heard, and that we hear a lot and we heard from the questions that were submitted were, can LED lighting penetrate the canopy? And this is a question that's actually quite complicated, and I'm just going to show a couple of examples here. So yes, LED lighting can penetrate the canopy, but there's a lot of caveats. It's going to depend on the light spectrum that you have. It's going to depend on the plant type that you have and the way that its leaves grow. And it's also going to depend on your canopy architecture. How many leaves are in between, the light source and where you're growing, and things like that. So the nice thing about LEDs is that they aren't just point sources. You're mounting them closer to the canopy. They typically are much larger than the incumbent light sources. So you're spreading out the light a lot more. And in the future, we expect to see a lot more optimization on lens distributions and things like that, where you really can change the distribution of light much more so than you can for the incumbent technologies. But there is an effective spectrum. And so this study that I'm showing on the screen here is from 2015. It's a NASA study that was done. And they looked at 7 different crop types. They looked at 2 different light levels, and they used 7 different kinds of, for the most part, narrow LEDs, right? So there's violet LEDs with a peak around 400. There's a blue LED at 450. There's green, amber, a couple different reds, and then a far red. And what you can see from the graph on the right is that for these 3 crops, at least, these 3 types of plants, green lettuce, cucumber, and soybean, there was no effect of light level. So even at 2 different light levels, they transmitted the same amount of light. For the other crops, there was a small effect of light level, but basically the trends are the same. Violet and blue light transmit very little to the crop, to the plants underneath. Green and amber light transmit a little bit more. Red light is not as good as green and amber, and far red transmits quite a bit, right? And this is just at 1 leaf. So you can imagine as you multiply the number of leaves that you start to see these big effects of transmission. So if you have a deeper or thicker canopy, you're really going to see not only a loss in PPFD, as you can see some of these transmission levels are really quite low, but you're actually going to get differences in your ratios, right? The spectrum at the bottom of the canopy is going to change. Your red to far red ratio is going to decrease. Green is going to penetrate much more so than red or blue. So this is why white light can be really, really great for LED, much more so than just sorry, you might want to mute, because you're going to get that multiple transmission through the leaves, right? And so the only way you're going to know this is if you measure. So, it's really good to take your quantum sensor, your light meter, and to measure at the top of the canopy. That's what we typically do in design, right? To actually measure in the canopy, at the bottom of the canopy, so that you understand not only your PPFD, but also your spectral composition. And in this case, I think it's really important to also measure far red, not just the PAR wavelengths, so that you understand exactly what's happening to the plants down below. And then finally, the nice thing about LEDs is that they can be used really close to the canopy and even in the canopy, which means that inner lighting LEDs can be used within the canopy to bump up your PPFDs and also potentially to change your spectral mix so that it makes sense for you and the crop you're growing.
Hey, Leora, I got a quick question for you before we pivot here. For folks listening who are on the cultivation side, like I know every time a grower starts to get hip to PPFD, and then they start hearing people say, measure across the canopy, measure at the top, measure at the bottom. What do they need to go Google to look that up? What device do they use? What sort of meter do they use? Can you describe when, like, where would they get access to that? So that they can start to, inform themselves and take measurements, or who do they work with to get access to that sort of information?
Sure, that's a great question. Well, as you can imagine, there's a wide range of price between sensors, and usually price is an indication of precision in this case. So what you're looking for probably is something that says a quantum sensor, or it actually uses the word PPFD in the meter. And those kinds of meters typically just measure PAR, right? So they're going to measure between 400 and 700. And there's some variances between them depending on the detector that they're using, right? And those are often related to price point, to be perfectly honest. It's a little bit more difficult to find a far red meter that is commercially available, one that's sensitive to far red. There are some new meters that are measuring extended PAR or EPAR from 400 to 750, especially from one pretty well-known manufacturer. And those are going to measure the far red for you as well. But if you don't measure it, you're just going to make assumptions about what's there. And as you can see, even from this limited data, and there's a lot of transmission data that's out there, there's going to be wide variations in your canopy. So decide your price point, figure out what you want to buy. And as you do this more and more, you may decide to buy a more expensive meter. Just play with it and see what you think.
Well, and I'll say this for folks in the cultivation community, with all the different ways to manage that canopy and determining how thick you want it to be and how much you want to thin or not thin, boy, wouldn't it be great to actually have some readings above and below to tell you what what levels of light are getting through or reaching the bottom. So Leora, I want to pivot. You just gave a really great comparison. We were talking about how LED compares to HID in the light output sense and in the efficiency sense, and how light penetrates the canopy. But let's pivot a little bit and talk about how these two technologies compare on the environmental sense. I know you prepared a slide to talk about that.
Yeah, thank you so much. I'm excited to share this, although let's just say that we're in early days right now. So in this case, this isn't a clear yes or no, right? Whether or not LEDs are better or worse or the same as HIDs, right, is a complicated question, and it really depends on which sort of levels you compare it at. So the easiest answer is you need to compare one or two things, or possibly both. First, you have to compare the material information. What kind of materials are in there? Are they hazardous to human health? Are they hazardous to the environment? How do those compare? And there's quite a few efforts underway worldwide, and actually regulations in Europe that are making this easier to do. And they're starting to come to the US, which is very exciting for lighting. The second way we can compare data is in terms of its climate impact, and that's by looking at the life cycle carbon costs. So let's start with that. If we want to compare carbon costs, we have to actually look at two components of the product. The first is operational carbon. How much energy does it use, and what does that have to do with our carbon use and greenhouse gases? And then the second one is the embodied carbon, which is how much carbon is produced when you manufacture, transport, or install these products, right, on the same sort of unit basis, so on a fixture to fixture basis, let's say. So it's pretty easy to understand, and it's well verified that LEDs reduce your operational carbon, right? Because you're using less energy. And as I showed before with those graphs, the energy efficiency of some LED products compared to incumbent technologies can be 50 or even 100% more, right? Depending on the lamps that you're using now. So that's an easy win. The embodied carbon is a little bit harder. There's a lot of efforts underway, starting in the European Union and slowly making their way over to the US, about how to quantify embodied carbon so that you can make comparisons between products. And so these are typically shown with material transparency labels. And the real answer is they're not readily available for lighting in the US now, let alone for CEA lighting, which is an even more specific use case. So it's worthwhile to ask the manufacturers that you're looking at if they have this kind of data, if they're pursuing this kind of information in the future. But I think honestly, it's going to be 5 or 10 years out until we readily see information from manufacturers. But the more you ask, the more it's going to rise to importance for them. The second way we can look at sort of the better for the environment axis is in this material info. And so on the hazardous substances end, you can start to look for RoHS compliant products. And so RoHS stands for Restriction of Certain Hazardous Substances. It is a European Union directive. It's on its third sort of revision now. RoHS 3 is the one now. And essentially what this does is it restricts the inclusion of materials for electric and electronic devices like lead, like mercury, like cadmium, and there's a bunch of others in order to make them more environmentally friendly. And so the nice thing about RoHS compliance is that it has been rolled in, or it's part of the CE marking as of 2011. So if you see a CE mark on the spec sheet of a manufacturer, it's good to confirm that that also means RoHS compliance, but it's pretty likely that it does. That's a good way to see if there's less hazardous materials in that product. And that's something to also look for. So I think that's an easy thing to ask for and an easy win. Ask the manufacturers if they have material transparency labels, if they're pursuing them. Also ask if the product is easily serviceable, right? Can you replace products down the line, or do you have to start with a brand new fixture? And what are their end of life programs? You know, do they take back the products, or do they have disposal methods readily available that allow the product to be recycled in the future? So I think all of this is really exciting, but to say that, you know, one product is always better than another product specifically is not something that I can do, and something that you have to ask about each time.
Sorry to interrupt here. Thanks for the conversation. I do want to do a time check here. We need to move on to our next section. All right.
Perfect. Thanks, you guys. Talk to you later.
Hey, that's awesome stuff, Leora, and I appreciate DLC and the audience asking about that, because you know, it's awesome. We may be on the vanguard. This stuff may be in its early stages, but it's super important, and makes me feel better knowing it's being worked on. So thank you very much for that. That was great. I know there were some questions that came in, and we're going to have time for those hopefully at the end. That's why we're marching forward here. So keep sending those into the chat. And then we're going to pivot to myth number 2 here. This one, I'm excited to tee this one up, because this is like where the rubber hits the road. A lot of the growers, a lot of the cultivators in my community that I talk with, they're what I would call LED curious now. They originally were like, no, I don't even want to deal with it. But now they're kind of like, okay, now that I understand PPFD, now that I understand how I can measure this, you start to think about some of the practical stuff, how this is really going to come together. Is this going to increase productivity? Is this going to work for my operation? Erico, I know you're going to talk, you're going to just lay right into this, but maybe just to go one step further, probably the most common thing I hear from people is, what is this going to do to my crop? Explain to me what this is going to do, not just to the crop, but to the, you know, my overall environment, right? Help me understand what to look for so that I can be prepared. I'm not just buying these LEDs and then flying blind. Erico, why don't you take it away? And I think some questions will probably come up as you start laying out, you know, giving us your insights.
Sure, thanks, John. Yeah, and that's a question that we hear a lot as well. So hello everyone, Leora, thanks for the presentation. Thanks the DLC for the invite, and hello everyone, thanks for joining today. Great conversation to have. My name is Erico Matos, and I've been working as the Executive Director of the Greenhouse Lighting and Systems Engineering Consortium for the past 4 years. And in this role, right, doing the interaction between academia and industry, we hear most of those questions as well that John mentioned, and some others. So hopefully we can talk a little bit about some of those points here today. The myth that I will be working around is my grow or crop quality will be negatively impacted using LEDs. So making a segue from what John just mentioned, how an LED lighting system would impact my production system. So the first question, how will LED lighting impact on other areas of my grow? So this one is interesting because the original question was, will LED lighting impact other areas of my grow? And the answer is yes, absolutely. So now we're going to take a look, how would that happen? For this talk today, we don't have time to go into data into each one of those. So we decided to provide an overall description with a few examples, and I'll be happy to answer more in-depth questions at the end of the talk. What will happen if you change your LED lighting system? You can't simply change a system at your production facility and expect that that's not going to impact anything else. When you're growing a crop, everything's pretty interconnected. Depending on the lighting quality, the lighting amount that you have in your room, you will induce a certain amount of photosynthesis. Leora talked a little bit about the spectrum impacts on the crop. You have light penetration, but if you're changing the lighting system, now we're probably going to be looking into a different temperature into the room as well. You have the CO2 control that can be controlled. You have the ventilation control, humidification. So just a quick overall into those systems here. Water and nutrients uptake. So we know, right, VPD, the vapor pressure deficit can really impact transpiration into the plant. And that'll be the system that is bringing the water to the plants and taking the nutrients, so not only to the plant, but cell to cell. So if you now change your LED lighting system and you provide more or less light, you induce certain receptors of the plant versus another if you have your traditional HPS lighting. That compared to the temperature into the room, you will be affecting those aspects. This is not necessarily bad, and I would argue the other way around. You're just a change. You're optimizing one part of your system, which is one of the most energy intensive one, which is lighting and driving the photosynthesis. So you make tweaks and adjustments to the other parts of your control room, so you can optimize and you can get a much better overall production at the end of the day. One of the aspects I would like to talk a little bit more in depth here, I took the example, and you see there is always a blue bullet point here, is CO2 control. We know that the plants can respond. You can control lighting and CO2, you can optimize the photosynthesis process with the plants. What you see in this graphic here is a relation between, if you increase the intensity, the concentration of CO2 in your room, your plant's gonna photosynthesize more efficiently, so you can use less light. So what this graphic is saying is that you can achieve the same amount of photosynthesis if you increase the concentration of CO2 and you use an equivalent of 0.8 hours of lighting versus if you maintain the CO2 levels at about 400 ppm, 400 and 500 is what we have nowadays, will take 1 hour of light for this specific light intensity. It really shows the relation here that, again, if you're changing the lighting, you might think about changing the CO2. And if you make a change in one of the systems, how that impacts the other. If you change now the CO2, if you're concentrating, enriching your CO2 room, you have to be careful how you're going to control your ventilation. You don't want to blow up, increase the concentration of CO2, and then just activate your ventilation and blow all the CO2 away. When you take in consideration all those factors here, you can think about dehumidification, how you maintain the right DPD levels at your room. So then you don't get disease, you can have the correct amount of transpiration, nutrients, movement into the plant, and that pretty much come back to the loop again, right? If you're not talking about the dehumidification, what that makes your water and nutrients uptake. So it just really closes the cycle here based on the light switch. So again, it's not bad, I think it's good, but you have to consider everything else. If you simply replace the lights and expect that nothing gonna change, you're not gonna be happy. Next slide, next myth. Does making my LED lighting smart actually improve productivity, profitability? This is an absolutely yes. Lighting controls, sensing technology is evolving really fast. We have a lot of systems available, home growers to totally automated production facilities, multi-acre facilities. Few examples here. If you want to achieve crop production consistency, which I think everybody wants to do that, you have to ensure consistent lighting conditions. If you're a greenhouse where you have the variable weather conditions, you have the sun going up and down, you have winter, you have summer, fall, how do you respond to that? So having a smart lighting system, you can sense those changes in the environment, and then you can respond to them to achieve consistent lighting condition to the maximum capacity of your installation, right? Of course, you have to understand, you're not gonna design a whole lighting system to provide you the ideal amount of light during the darkest day of the year, because then the operational costs or installation costs are going to be tremendous. But you can certainly take this in consideration and come to what is reasonable. If you can do that, you will realize energy savings. So if you're ensuring consistency during the dark months of the year, you can definitely realize energy savings when you have more sunlight available. You have months or days in which your lighting is going to be going up and down, and you're going to be over illuminating if you don't have a smart control system. By sensing that, you provide lighting just when it's necessary and you save energy that way. That takes you to my next point, systems integration. We just talked about how your lighting system, if you change that, all the other aspects can be impacted. So if you allow to have a smart lighting system that can be integrated with other sensors and controls, you have a much more precise control of your operation conditions. Data analysis is really important. I think if you want to optimize your system over time, we're going to take a look on crop to crop later on. Crops, they are very specific. So through the data analysis, you can understand what you're doing, what are the impacts of things you're doing. You can look back, you can cross information, and you continue to optimize your system, which leads to the next one, crop specificity. Having a dynamic lighting system allows you to take a fixed installation and really tailor and adjust to the specific needs of your crop. And that could be whatever you're growing, vegetables, ornamentals, propagation, cannabis, hemp, anything you're doing. Next one.
Erico, can I ask you a question on the last slide?
Yes, absolutely.
So real quick, you're saying, yes, absolutely. It's gonna, you can achieve greater productivity, greater profitability. but speak a little bit, tell our audience, like, if you're investing in this sort of system, all of a sudden you're using words like system integration and data analysis. And I don't care how good your green thumb is, that doesn't necessarily make you a good data analysis, a data analyst, right? We're talking about kind of different skill sets here. So it seems like, in addition to investing in these lights, it seems like utilities like to use the word total resource cost, or I guess economists like to use the word total resource cost. Are we talking about an investment at this point? When you're talking about all this stuff coming together, are you talking about an investment that goes well beyond the lighting system at this point if you want to achieve data analysis and system integration? Just help paint a picture for me. Is it as simple as when I upgrade these lights, or are we talking about sort of multiple tiers of, to achieve what you're describing here? This is maybe a tier 3 as opposed to just changing out the lights as tier 1.
Great question, John. No, I think the technology makes it available for any grower. It can be for, for a single home grower to a very large installation. You find smart lighting controls for everything you do. You have dimmers, you have timers, you have adaptive lighting controls, you have threshold controls, and we can talk how each one of those work. But there is a solution for everything out there. I think if any grower has the money to invest in a lighting system, they should make the investment on a lighting control system. That will give you, the most basic controller will give you 10% to the most advanced, up to 50, 60% if you have no controls at all. So if you are installing your lighting system, look for a smart lighting control. And again, there is a wide range out there. Utility companies are now, doubling on that. They are giving rebates on that as well. Everybody knows about the rebates on the lighting itself, just by being more efficient than it is. You can get rebates on that. But now the utility companies are looking into the controllers as well. So there are financial opportunities out there to get that. To your point on the data analysis, people are working to make it as simple as we can for the industry. Think about, I'm in New York, I have National Grid as my utility company. Every month they send me a one-page summary and tells, that's how much you use, that's how much your neighbors use, there is a happy face or a bad face. So people are doing that way now. We can do something as simple as that. We can show how much sun you got, how much supplemental lighting was used, and did you get to the target, yes or no? How can you optimize that? What can you do? You improve your system, you decrease your system. Can you do anything else? So we are doing things like that. And you can see from the major lighting control companies are all working towards that way, even in terms of units and measures, right? Making measures that make sense for the grower, easy to understand. So great question, John. And I think always look for more information. There's always more resources there to help you to get there, but there is solutions for everyone nowadays. I think the biggest mistake is not looking for more data analysis and understanding your system. You're leaving money on the table and you're being not consistent and productive as you could. So to the next ones, this one I'm going to go through relatively fast. We're going to hear more about the economics of the LED lighting. But here's an interesting one. If I have everything set up and ready to go fine-tune to my double-ended HPS, why should I change? Well, because what I just talked about, to improve your productivity and profitability. I think a key point to understand here, if you are a commercial grower, if you're a hobbyist, that's okay. If you're a commercial grower, technology is evolving fast. Rebates are available today, but they might not be for long. We're going to hear more about this in the next speaker. If you are not cost competitive, cost effective, you're going to be a hard time to be in business in a few years from now. Well, some industries are already like that. If you think about the ornamental, the vegetables, competitive is really high. If you're not inefficient today, you're not in business. But especially the cannabis, the hemp industry, you have to be competitive. So that's why you should be looking to change and optimize your system. If there is a new technology, you should go for this new technology, understand, and keep applying. So a few quick points here. Considerations before you make the change, right? We understand there are restrictions, otherwise everybody would get it's expensive. So take a look at the capital investment, understand what would be the capital investment to make a replacement, or if you're installing or if you're expanding, going with a better technology for your next build. One time you know the capital investment, what are operational expenses? So you start to understand how much you can save on a monthly basis, depending on your technology, the size, your crop, and so on. take advantage of the rebate programs. There are national programs run by the USDA, but there are a lot of local, state level programs run by the utility companies. They will help you. I know most of them, they even have the energy audits for free. It is beneficial for them that you are energy efficient as well. So they can come, they can help you to understand how much you're using, what is the baseline, how much rebate can you get on the lighting systems, but also, John, to your point again, on the controllers, you can get rebates for that as well. Understand that, and then financing opportunities. It is expensive to come up front, yes, but are there financial opportunities? Yes, there are. With all this information in hand, you go to the return on investment. I think the bottom line is always that, right? What is the ROI? Is that feasible? And more the time goes by, Laura talked about this at the beginning, the advances in the lighting industry has been impressive over the past 5-10 years. And it just become more cost effective, more powerful. Take a look at the return on investment. We think we're getting close to the inflection point, if we're not already at the inflection point. So if it's ready for you, just make the transition. For the next slide, do LEDs only work for certain cultivars or for crops overall? The answer is overall. It's lighting, you optimize lighting. And I think that's, just reinforces this point. Different crops, they have different requirements. If you stuck with your HPS lighting system, you have what you have. Your crops change the requirement, you're stuck. The environment change, you're stuck. You get other systems, better integration, you're stuck. So the LEDs allow you to do all of that. In my point of view, the biggest benefit of LEDs is not really, well, not really. Energy efficiency is great, but the controllability of LEDs is the greatest thing. You can adapt, you can change, you can customize to your needs or to your crop needs, to your location, to your other systems. That's a handful of features and projects that I've been involved. And you see there are greenhouses, indoor, there is leafy greens, there are propagation, there are ornamental crops, cannabis, hemp. So it can fit all of those needs. Another important point here, do not generalize. So if you find something that works really well for one set of system, one crop under certain conditions, don't think that that's gonna work for everything else. That's a common mistake. People go, they find one research, one paper that said something, well, I'm gonna do the same. Everything changed. In your own facility, if you change another system, that was our first slide, things will change. So be mindful of that. And then goes back again, data analysis, tracking what you're doing. You can optimize over time. So really keep that in mind. Now, my last slide, I'm getting close to my point here. What is the spectrum, what is the best spectrum or color temperature of my LED? So that's the $1 million question, right? Everybody asks. There is no right answer for this. That's the bottom line. What we try to do with Glaze and the other initiatives that I work with, we try to inform the grower, the client, to learn as much as you can about a lighting system, how to compare lighting system, what are your needs, and then you can come to this conclusion. There are many resources out there that you can seek more information. We're gonna share our contacts at the end of this presentation, but take a look at that, contact us. So just quick bullet points here. Consider if it's indoor or greenhouse. The main point here is if you're indoor, if your lighting is 100% electric, so LEDs or HPS, the spectrum is gonna have a much higher impact than if you're in a greenhouse. In a greenhouse, we have the sun as a buffer. It's much more light you get from the sun than from a supplemental lighting system. So the impacts are lesser. Here is more about quantity than quality you can consider. When indoor, quality is really important. And when I say quality, is a spectrum and quantity is amount of light. What is your application? You're flowering, you're avoiding flowering. It's propagation, you want to keep your plants short and tight. You want to expand the leaves. You want to change the coloration of your letters by inducing pigmentation. Think about all these applications. The spectrum play a big role here. Efficacy. So you're looking into red and blue versus white LEDs. What is the efficacy? So thinking about here, how many micromoles of light you get per energy, unit of energy. EPAR, this is what Laura talked at the beginning. Everything nowadays pretty much recorded between 400 and 700 nanometers. That's the definition of photosynthetic active radiation. There's a lot of talk now and data supporting that we should consider the extended PAR, which goes all the way to 750, pretty much accounting for the impacts and effects of far red light, what it does for the photosynthesis process of the plant enhances, and you have morphological impacts there as well. And my recommendation to close my talk here on time is lighting label. So this is the lighting label published by AJ Both at Rutgers University, and really helps you to identify those key metrics on your lighting system. So it tells you how much light you have within the different ranges or colors of your fixture, talks about general aspects of the fixtures itself, some efficacy numbers, the spectrum distribution, photosynthetic activity, phytochromatic activity, the ratio of fret to farad. There is a lot here. I'm not going to have time to unpack, but take a look at that. Look for the this paper, Proposed Product Label for Electric Lamps Using Plant Sciences. There is a lot of information there, and happy to talk more about all of that at the end of the presentation.
Yeah, that's awesome, man. So much good stuff, Erico. And if I wasn't watching the clock, I would just be feeding you more questions. So as it is, I'm going to pivot us directly to our third and final myth for the hour with Lauren Merlino. LED products are either unaffordable or untrustworthy. Lauren, is this just two halves of the same coin? I suppose a product can be both expensive and untrustworthy. So that would be the worst of both situations. But why don't you help us understand some of the macro trends and talk to us about, what does reliability mean in practical terms, and what can growers do to give themselves a more, informed and empowered position to make decisions?
Yeah, sure. Thanks, John. And can you see my screen okay?
Yep.
Okay, awesome. Yeah, so hi there, I'm Lauren, and I'm a technical manager at Evergreen Consulting Group, focused on program design for controlled environment agriculture customers. I was asked by Casey and John to bust our third myth today, which is LED products are unaffordable and or untrustworthy. And so to me, this was kind of getting at two themes that I decided to break down for you today, which is affordability and then reliability of the products, as John was just hinting at. So first, let's start with affordability. As LEDs become more mainstream, first cost is still the main concern that I hear from growers with regards to LED. LEDs are definitely coming down steadily over time in price, but I would say even more than that, manufacturers are introducing more models for differing needs and price points every day even. And so when we first started rebate programs for these lights, there were maybe 18 products on the DLC list, and now there's around 500. So it's been growing quickly and at a steady pace this entire time, with lots and lots of variation kind of baked in. LED lifetime is 5 times as long as metal halide bulbs. And so I hear from growers all the time, it's worth it to me just so that I don't have to pay somebody to go replace the bulbs every 6 to 9 months. And then you're paying for the bulbs that often as well. So your LED kind of return on investment should incorporate all of the avoided costs associated with your existing technology. Someone actually asked this question in the chat, and I hear it very often, which is why are the DLC lights more expensive than other products I've found on Amazon? And honestly, there's a wide range of LED product prices and quality in the market, and DLC really helps us sort out that quality. Quality comes at a cost, and DLC certifies that third-party testing has happened and that things like warranties for products exist, which helps with cost long-term, because you know that the products are going to last. Chips, boards, drivers in products are going to be, subject to quality concerns because they need to perform for a long period of time. They will also be subject to the rigorous tests that DLC requires if they're on the DLC list. And these lights are really high-powered systems, right, that we're putting in our businesses and homes. So it's important to be careful about what you're really plugging in. For example, would you buy a refrigerator for your home from a brand that you've never heard of delivered by Amazon? Or would you rather buy a kind of name brand one that you can find at a box store, a business that's been in business for many years? It's kind of that type of comparison. They're high wattage products that we're trusting in our homes and businesses. And I would say too, feel free to ask manufacturers and your utilities if you can try small quantities at a time. We have definitely incentivized test fixtures for commercial customers if they want to try a couple fixtures side by side, see how it grows, what they're trying to grow, and then make a decision on how to scale up for a larger business. That's totally something that that manufacturers and utilities can work with you on. With LED, you also have a potential to dim, so that can lead to energy savings, as Erico mentioned, and demand charges. So in a greenhouse, you can dim according to how much light you're getting from the sun. In an indoor grow, you may be able to dim depending on what the plants need, or even to help reduce load during a peak event, which could translate into more energy savings on your electric bill.
I'll say this real quick as we pivot to reliability. When we just had that major heat wave in Portland, we had 2 of them this summer, and these dudes who said they would never, ever, ever dim their lights, well, their AC was tapped out and they couldn't dim their HID lights, but they needed to, so they had to go around and manually turn a bunch off to keep the room. So it's like, you don't know when you're gonna need that control, and there's a reason, you know, you might want to pay for it. All right, couldn't leave that gem on the table. Lauren, take us home.
Yeah, exactly, John. It opens up a whole other door for resiliency for businesses as they just look forward into forecasting new challenges for themselves. Yeah, so let's talk about reliability. DLC gathers information about really important product performance testing. As I mentioned, the products on the DLC list are tested by accredited labs throughout the country. For example, test data is reported for the lifetime of drivers and fans, which is important because these are the most common points of failure in these LED systems. Also, photon flux maintenance, which ensures that products are performing well and maintaining their light output over time. Ambient temperature testing is important because these test how the products hold up in high room temperatures, closer to what the product might experience in a real life grow room. Warranties are really crucial to me when you're looking at investing in this technology. If something goes wrong, this is basically your insurance policy. It points to legitimate manufacturers, in my opinion, who can back up their claims. There are legitimate manufacturers that go out of business, but the DLC kind of helps organize companies who have better technology, customer service, research and development, future forecasting of their business models. You know, you really have to kind of have your integrity together and customer service together in order to pass the tests that are required. There's a lot of fly-by-night manufacturers out there, especially in this industry. We often hear from growers that they tried LED and then they went back to the manufacturer with an issue and they were ghosted, or the manufacturer did not exist anymore. Make sure you vet the manufacturer as much as you're vetting the product itself. What happens when you call the customer support line? Do they help you with grow room layouts? What's the process if a light has an issue or a warranty claim? Spectrum, another thing that a lot of growers ask about. The DLC list provides information about spectrum and how much spectrum is provided in each kind of category of light in the electromagnetic spectrum. This is something that you can go in and compare your existing high pressure sodium fixtures to a new LED fixture and make sure that your plants are going to be happy under a new technology. Safety certifications, also really important. We want to keep fire safety and electrical safety front of mind. These products are safer for everyone involved, whether that be utilities who are helping pay for them, contractors who are installing them, customers who are operating them. Safety considerations are you know, really important to the DLC and not so important to Amazon, turns out. And finally, perhaps most importantly for utilities is efficacy. the lab testing that DLC requires tests actual wattage of the fixtures and actual wattage in and PPFD out. And so this demonstrates that the product is actually working in alignment with what the manufacturer's specifications say it's supposed to do. It allows growers and utilities to be certain that the corrective amount of power is being supplied to the fixture and that energy savings being claimed and reported to whatever state the fixture is installed in are accurate. So thanks so much. I'm happy to answer any questions, of course, in the Q&A and after as well. I put my email up here on the next slide. And yeah, thanks to DLC for asking me to be part of the panel, and thanks to the other panelists as well. These are the folks that I call when I have intense lighting questions. And so I'm really grateful for their time and to be here with you today. And if you have any questions about how rebate programs work, or if you want to set one up in your territory, please reach out. Thank you.
All right. Thanks, everyone. I'm going to go ahead and spotlight you all. Hopefully that'll work. I'm not sure how this works, actually. All right, so you should all be spotlighted, and I'll screen share. We have a few minutes now. We did go a little bit over. We got a couple more minutes for the end of the webinar to tackle a couple of these questions that ended up coming on through the chat. I guess we can start at the beginning. I actually just lost my chat panel once I started sharing. Maybe, John, could you read through those?
Well, I know there was one I think we should really prioritize or I think is important. So Lauren, can you just kind of really high level speak to, there are utility incentives. Most utilities require DLC, and unfortunately they're still different utility by utility. So you have to go to the utility to figure out what they're going to be. That might answer the question right there, but I want to make sure we talk about rebates since that question came up.
Yeah, exactly. Most commercial businesses are eligible for rebates in most places in the country. If you don't know if you have rebates, call up your power company. That's kind of the best first stop, or your energy efficiency utility if you have one of those. Residential grow light offerings are becoming more popular across the US. And I would say now is the time, because these LED rebates aren't going to exist forever as other regulations and energy codes start to creep up and require LED. You're not going to get rebates forever. So definitely act now, I would say.
So I want to give this next one to either Leora. Leora, I think you might want to field this, or Erico, you might jump in. Does DLC plan to balance PPE versus spectrum with future requirements? There's more to that question, but I think I'm just going to leave it right there for now.
Yeah, certainly when we're looking to raise our thresholds, we are considering the capability of LEDs to do that, right? So we know far red is efficacious, potentially even more efficacious than other spectrums. So we're going to take that into consideration as we raise the criteria. But we also have to balance that against the current definition of PAR and PPF, which limits it to 700, right? So in the end, if our criteria continues to be based on PPF, and until or whenever that metric is adopted, or an alternative metric is prescribed and standardized by ASABI, and then able to be measured by test labs across the world in a consistent way from one place to another, we have to balance out those two things. So we're keeping an eye on this carefully, and we're participating in standards activities that are also looking to change the definitions or augment the definitions.
Hey.
One quick comment there, John, is so the rest of the question was talking about, for example, hypothetical scenario, you just make a light that is only red. Great PP, right, for synthetic photo efficacy, but not really good for the plant. So I think there's some common sense here. Of course, you're not going to go with that, but I'm not saying one is better or worse. What I'm saying is, I mentioned that in a greenhouse, for example, the impacts of a red and blue or a monochromatic LED are lesser on the quality side versus in an indoor facility where all the lighting is coming from this electric source. So keep that in mind, right? You're not going to be able to come up with one gold answer again here. You have to get good sense here, common sense, and see there is a well balance, and go back to the DLC, get this information, look into the lighting label, compare for your specific need. Because if you're trying to look for one gold bullet here, you're not going to find.
Yeah, and I'll just add just really quickly, we plan to show the SQD, the spectral quantum distribution of every product on the QPL. So you'll be able to compare those and then reach out to the manufacturers and ask more questions.
Yeah, and Jeff, just a seg up for the previous question as well. Lauren mentioned about the LED lighting fixtures, but controllers are also getting rebates now. So ask for the controllers as well.
HVAC, really anything that's happening in an indoor grow, ask your power company about rebates.
All right. Hey, shout out to all those utilities putting their information up there. I love that, especially Idaho Power. I don't know why. That just makes me extra happy knowing you guys got a Hort program. So Casey, I'll let you take it home.
All right. Yep. So we're at time. We're a minute over now. Thank you all for staying. Make sure to send us an email if you got any thoughts. We do plan to send a post-event survey. So keep an eye out for that. Your feedback's really important for us to make sure that the content we're covering is, right for you guys, and that we can plan to have more content coming your way in the future. So thanks again. And if we didn't get time to answer your questions that you submitted, we will be following up. So thank you.
Thank you.
Thank you.
Bye, everyone.
Thank you.